Hi everybody, this is Tyagarajan. Welcome to the website vtrenwgsoft.com. So in this video, I would like to explain about the application for longitudinal track profiling, so otherwise called as top tracking. The top tracking is nothing but correction of unevenness existing in the surface, the longitudinal plane, maybe either road or railway track. So why this correction is essential? Everyone knows that maybe road or railway track, the surface is not smooth, not uniform, having a lot of undulations. So when the vehicles are running over the road or track, the riding will not be smooth. That will give discomfort to the passengers. So in order to ensure the smooth surface, so we need to correct the surface in one line. And this application facilitate giving you the solution. So once you are recording your existing profile, the feeding the data into the application, you will be getting the solution, that is the various point, the amount of lift required in order to get the smooth plane. So coming to this, we call, just see, this is your existing profile of the road. So you want to make it, to uniform plane. For example, so connecting this two points, we'll have a smooth plane. And to get the smooth plane, so this much lifting is required, this much filling is okay. Suppose we are recording our existing levels. That means we civil engineers know, so we used to take the fly level and we are reducing the level. So at regular interval, if we are able to get our existing reduced of the road profile, so with this data through the application, we'll be able to get the amount of lift. For getting this plane, each and every point, how much lift is required, how much filling is required, so that can be applied. So using these values, you can apply on the field, you can get the perfect smooth plane. So coming to this, the facility available. So if you take a road or railway track, there will be some down gradient and up gradient. Falling and rising gradient. So normally the up gradient followed by the down gradient will form a sag. This is a point, it's called sag. And the down gradient followed by the up gradient forms a summit, the apex point. So these two type of locations we should take care. So we cannot abruptly take the change of grade, and that location, the point should be smoothly connected. So as far as this application is concerned, it takes care provision of the vertical. So it provides vertical curve so that it will ensure the smooth passage of vehicle over these points. So this is one of the facility available here. Then coming to the concept, see, this is our existing bed profile. So we want to have the smooth plane, smooth longitudinal plane. That means if you are connecting the point A and B, it forms a straight line, it will be uniform. So sometime what will happen, in order to get the smooth plane, so some portion need to be cut and some portion need to be filled. That means this portion to be lifted, this portion to be lowered. Sometimes it may be possible on the field. You can do the lowering also, you can do the lifting also. But some cases, some situation will arise, and there you will not be able to do the lowering. You cannot do the cutting. At the same time, the filling also, if it involves too much, you cannot do that much filling. That means, for example, in case of track, you cannot lift that much. So in that case, also, so you will get the smooth plane using the various options available in the application. You will get a via media, surface that takes care of your options. You are restricting the lift as well as restricting your lowering, and that will certainly facilitate smooth riding. For example, here I'm just we are supposed to connect 2 point A and D straight line. When you are doing it, there is a cutting involved. There is so much of filling. So we don't want to do the fitting. We are connecting the point A B, so that this the location, the point at the point B, we are avoiding the lowering of surface. At the same time, we are connecting the B and D. This much filling involved. So this much filling we cannot afford. Only, for example, maybe 1 meter filling is required. We cannot afford that much 1 meter filling. We want to restrict to 30 centimeter and 1 foot. You can give the option accordingly the point 30 centimeter. So it takes care and connecting the instead of connecting B and D straight away. Here you are want to restrict it. That there will be the plane BC and CD, and at the point of C, the lifting will be restricted to 30 centimeter. And wherever you know the the change of grade is there, the smooth connection is ensured by providing the vertical. So, so this is a facility, and to get a clear idea about the application, so we can directly go to the application, see how it works. So we can open our website. This is btrenwgsoft.com. This is website address. This is our page, home page. So here we have a lot of optional menus there. Home, application, software about us. So this is the application portion, and these are all the items available. And the first two cases already seen. Ethor Corporation. And third one now we are looking into this. Clicking the surfacing, launch surfacing. So this is your longitudinal track profiling page. Here, so for getting this required solution, you need the data, input data. So that means what, as already we have discussed, the existing levels, the various points along the alignment of the road. So we are collecting, we have to take, and here that is to be recorded in our Excel file, the prescribed format. So importing the data from the Excel file to this application, so we can get the solution. So how the Excel file format should be, and for your convenience sake, so I'm just button provided. It's called ERL data. So that is your sample input data here, sample file. Clicking this one, you can get the sample of Excel file. The format, same format, you can use it for your case also. So first, using this, file will work out how the application works. Okay. So first, let me download this file. Okay, now this is our Excel file. As already discussed, we need the existing RL of various points. That means our Excel file should have these headings: 1, 2, 3, 4, 4 columns. And the first column is ID, that is, you can just put serial number. Second column is your the reference, some chainage you want to refer, the column is provided. This is station number. Station number, I just start from the 20, example sake, and you can start 0 also, 0, 1, 2, 3, like that. You have the station number. And station inter distance, I have just kept here 15 meter. So every 15-meter interval, I'm taking the existing reduced levels, fly level I'm taking and reducing the level. So this is your existing levels from station 20 to the end, and every 15-meter interval I've taken the levels. So this we have to be very careful. The whatever input data you want to use the application, it should be in the Excel file, a similar format, similar. Same thing, you copy it and you change your data. But here, you see, don't add any additional column, additional row, column attached. Okay, so this we can save. Now, the same file we will just use it. The application. Let's see how it works. Sorry. You can save desktop. This is just save LT profile. Input. You can save. Okay, this is our input data, existing oral data. So let me close this file. Go to the application. Now we can import the data. Okay, so click the import data button. So the box is opening. You can browse the file location. So we have input data, something na. What input data? LT profile, I think input data or something. This is LT profile input. Just browsed. So click this button. So after browsing, you have to click the ERL button, so that this will be imported to application. The data will be imported to the application. So now it's imported. Your complete data is now the table now. That is chainage, reference chainage. This is from 20 station. We have the existing orals, every 15-meter distance. This is station first. So according to this data, it's coming. Station beginning, this start is 20. End of station is 140. Station number, this is station number. 20th station is 140 station. So station interval between station, the distance is 15 meter. Okay. So now you have to go for calculate. Once you calculate, you will get the proposed level and lift, how much lift is each and every point to get the proposed plane. And the grade also it will work out. Each between station, how much grade we have. That unevenness also. Between stations, you have the unevenness also. So all these things will be calculated. Before calculating, and you have to set this option. There are maximum lift. Here box is there. Here also text box. Here for maximum lift. So as already we have discussed, we want to correct the surface. It will connect all the high points. Connect the flat point. Sometimes we want to connect, and we are connecting it. There will be huge lifting is involved. So That practically it is not feasible and cannot afford that much. So normally for smoothening, suppose the existing surface is there, some modulations you want to just correct it. So fine tuning you want to do. So some minimum lift you can give. So like that lowering also. Sometimes we cannot cut the surface also, but we can do the lifting. We can raise the level. But lowering also, if you want to permit, you can permit how much cutting you can permit. That option is not also available. As for the data, whatever, so I imported, it is for the railway track actually. So railway existing track, I have taken the levels. Okay. So shortwave should be corrected. The plane should be kept uniform. If that is the case, if you are keeping our bed very uniform, uniformly throughout the length, it is smooth. The running will be very nice and it will give very good comfort to the passenger. So I want to give the lift. I can't permit because track we cannot lift from 1 meter and up. So I want to give only the 100 mm maximum lift as option, and I'm not giving any lowering. If you are not entering any lowering, it will take as a 0. At the same time, here also, if you are not entering it, and it will take maximum lift of 1 meter, 1000. Otherwise, whatever you enter, it will take. So now I am restricting the lift, the maximum of 100 mm, and here also I am lowering. Also, I am not entering. That means 0 lowering. So next option is some obligatory points, the various places we want to restrict some lifting also. That also here the option is available, and you can give the station number, which and what station and how much lift you want to permit, so that you can enter. This portion we'll see later. Now with this Anandama maximum lift, you can work it out. We'll see the solution how it comes. So now click the calculate button. So now it's calculated. It's all online. So see each and every station, you have the proposed level. This is existing level. This is a proposed level. And each and every point to get the proposed how much lift is required is there. And proposed gradient between stations and unevenness also. Proposed unevenness. So these 3 points is made record. It is worked out. So this is now the solution we got. Okay, now you want to get the printout, and you want to see the solution also. You can have the display and you can export Excel also. So print. See, this is your just view it. This is our display. Here I will given maximum 100 mm. So almost 100 mm everywhere it is there. It's not exceeding 100 mm. Okay. But in one place 159 mm, but we have restricted to 100 mm, but this place 159 mm has come. So some place, in order to get the smooth surface, and it has to be necessarily to be lifted to this extent. Otherwise, you will not get the sufficient good surface. So that is because taking care and this kind of compromise must have. Otherwise, we can restrict it. If we are restricting it, we will not get the surface. Okay, that maybe sometime because of the erratic level also. The initial level when you are recording also sometime by mistake you will some figure you will miss out. In that case also, it will smoothly will make it, and you can identify also it is because of the faulty data. Okay, you can correct it later. So anyway, this you will see 159 mm, that is 137 station. It is we will see why that much lift is required. So this is about the solution you got, display. Then you can export to Excel file. Open. Okay, something background is there. Nice. You give yes something. Oh, this is your okay. Now Excel. Once you got the Excel file, you can save it somewhere and to even print out also you can take. Okay. So this is your the Excel file, the result. Then you can save it as somewhere again desktop. You can save it up. You can put some. Oh, again, you want to save some web page and all coming. You just it's better save it. Excel 93. Another thing I want to say, when you are importing the data, input data, so your Excel file should be in this format, Excel 93 2003 workbook, XLS. That is better. So normally, kindly just once forgot to tell beginning, use this Excel 97 2003 workbook XLS. You say. So otherwise sometime it may lead to some error. Okay. So now I'm saving. Now export any file it can be, but then I'm telling you the import data should be from the Excel file 97 2003 XLS file. Okay. Now I'm saying the output. I mean solution. You can put LTP solution. Something lot of things is there. Okay. I put 3. I'm just saving it. So now this output file has been saved now. Okay. So I'm just closing this Excel file. So going to the application now. So we have seen now result Excel file also output. Then we can go to the drawing now. So clicking the button drawing, we'll have some idea that profile, existing and final profile. So this box is open, plotting drawing. It is just asking station from to which station you want to see the drawing. You can you want to see minutely, you want to see some portion alone, you can enter this station number from and to, you can see. If you are not entering, by default take beginning to the end. Okay, don't now don't enter it. That means some station beginning to end. Clicking this button. Now this page is opening. You can give some sale of some 25. Show. Now you got the drawing. See, this is your green line is existing profile and the red line is proposed profile. So this undulation, you see now, you want to correct it, you want to make it like this, right? And each and every station, how much lift is required, you got that. So once you are lifting or filling, this amount, you will get the plane of red line that will be smooth compared to the existing plane. The running will be all right. And as already I was pointing out, no, that station number 137. See here, some we have fixed maximum restriction of 100 mm, whereas here 159 mm. So because of some dip, excess dip, so that should be anyway no, should be used. Otherwise, if you are restricting it, then you will not get the smooth surface. Okay, so can just you can just use the scale. 30 means show again it's slightly bigger. Okay, you can see here. And 40 also. Okay, like that. So now another thing, we want to use the obligated point option. Here this station some lift is there and we want to restrict to 0. For example, in some place they will not be able to do the lifting and for example, in case of railway track, you see we have the level crossing track, they can from one end to other end, and in between a lot of sometime we have level crossing gate, sometime station will be there. So level crossing gate we cannot lift. Once you are lifting the track more, what will happen? The approach road also to be lifted. That will cause increment to the uh, highway. Road user. That is why we want to restrict the lifting at the low cost. We want to maintain the level as it is, and the same time, and also sometime in case of station place and also you cannot lift more because there are some dimensions supposed to maintain the platform height. Suppose there we are lifting, what will happen? That platform height will be reduced and may lead to some infringement. That is why, like that, some obligatory points would be there, and those points and all should be taken care. And there you want to restrict the lift, and the station number, the particular station number, you can give your option. That is, you put zero. Lifting. So the application will, I mean, uh, consider that one, and accordingly you'll get the solution. Okay, we'll go now to the application. This is let us say the zero station something. Let us almost coming some 110. The 110 station we want to restrict our level to zero. So then we can close this also can close this application. Now at 110 station 110 your restriction, lift restriction is 0. After entering, you have to add. So just come here. Now, one option, an obligatory, that is a beginning station. Normally, beginning we don't lift. That is a station beginning 0 is there. Now, we want to restrict the lift at station number 110. So, add button. Click to add. So, added. So, 110 station. We want to restrict the lift. That means 0 lift only. So now after that you once again calculate. So like that any number of points you can add, but sometime even you restrict, sometime it will not take. That as I told you, some places it becomes must. Even it has to provide some vertical curve. Suddenly it not uh, lower or increase. It has to see the approach also, condition also. So maximum it will try to give one restriction whatever you feel. But here now 110 station our lift amount is 0. We will see now what is the result now. So 110 station number 110. So now we got the lift of 0. That is this level, both levels are same. This is 0. So just take it care. So we'll see the drawing also now. Yes, here station number 1, it has come 0. Some approach also is okay. So this you can check a printout, have some idea about the profile, what is the thing, what is the final. Okay, this I will close it. Here also you can take, we want to take printout, you can enter the station number and all. You can put whatever station number enter, it will come here also. Okay, so closing the drawing portion. So this is your application. So these are all the options available. And you want to add any obligatory points, you can one second you want to add now, you can just over that you write it. Some again you want to some here you want to do something 30 31 also, no? You can put 31 0 if you are adding it. So now 31 also added. There also you are restricted now. Again you are calculate. So again 31 also 31. So 30 0. So 30 0, it has maximum tried to take, but it is reduced from earlier some value, now reduced to now it has necessarily 20. Then only the approach will be you got to use it. So it is not practically I have not put some idea, but site condition definitely certain cases actual site condition we see, and it will take care and give you the very good solution. Okay. So this is about the top tracking solution. I mean application available at the website, and certainly it will be useful for the civil engineering. A similar way, this application you can use it for farming road also. See, first we want to make some embankment. That time on, so for that also you can use it. Using the top tracking, you can find out the center line proposed level, and once you fix your uh, embankment level, proposed level along the line, and accordingly you can set the other formation of cross section. And using the software earlier we discussed earthwork compression embankment, so you can find out the you know the volume of the earthwork right along the road element from start to end. Okay, I think hope I have explained you well. You understood about the application. I request all of you to use it. Okay, so thanks a lot. And the next video I will say about the next application.